the time and remind you when it's time to come to an end. So for this session, we have planned some demonstrators. The demonstrators are based on the things you already saw in the last 2 days, and yeah, I think that's a nice rounding off for this workshop to see what the demonstrators will show us. The first one is Arkopaul, Sarkar, and for the OntoCommons EcoSystem.
Okay, is it ready? Okay. Hi, everybody. So I will make a continuation from my last presentation. The microphone. Oh, okay. I will use the microphone and then use this laptop. Yeah. Yes. So I'll try to continue from my presentation, which I gave on the first day, which was kind of like an introduction of OntoCommons ecosystem. But then today I'm trying to show some of the components we have developed of the ecosystem, and then overall how it is coming up, and then how it will help in harmonizing the ontology engineering process. So, okay, I am Arkopaul Sarkar, and I'm a researcher from ENIT. And I work with work package 3, which is domain level ontology harmonization, but also involved in both work package 2 and also participate in work package 4, which are more like work package 2 is about the top level ontologies and mid-level ontologies, and work package 4 is more on the methodology and tools. So all of these comes together into OntoCommons ecosystem. And to refresh what we presented as a OntoCommons ecosystem, briefly, it is the stack of ontologies from the top level to domain level, and also the methodology and the tools. So together it helps in harmonizing the data documentation, and we have different elements and tools for ontology engineering phases. Now, so for data documentation, the need of ontology comes at variable need for different use cases. I mean, but this is a simple workflow which you can use to find that what you really need to do. For example, that of course you are sure that you need ontology for your project, but then do you have a suitable ontology for your data? If you already have a suitable ontology and that ontology is already aligned in the OntoCommons ecosystem, that means falls within that stack of ontologies, then you are you are in a good shape and you can start using that ontology. Maybe enrich the ontology with some of your application level concept, but mostly what you are concerned with it is to model your data, document your data, annotate your data with that ontology. So that is the situation one, we say. So there is no particular ontology development as such. However, you can also, it may be the situation that you are not happy with the ontology. You do not find that ontology is suitable for your purpose. But in that case, also we suggest, and this is a strong recommendation from OntoCommons ecosystem, to reuse the existing ontology rather than creating new ontology every time from the scratch. I mean, so you can use some, you need to find some existing ontology, reuse them, and that requires that you take care of the mapping between different ontologies, and there the OntoCommons ecosystem methodology of mapping different ontologies will help you. And the situation 3 is, of course, the standard situation that you need to develop a new ontology. Now, we will. Today I will kind of focus on the situation 3 that, okay, you need to develop a new ontology, but then I will embed some of the element from the other situation that how can you map different ontologies and then also enrich them if you are not really mapping rigorously different ontologies, maybe you want to take some of the concept from the existing ontology and reuse them. So those will be covered. So quickly, we adopt LOT methodology, and this is the standard flow of LOT methodology. And I will just point out that there are 4 main phases. Of course, there are sub processes, not going in there too much, but you have the requirement collection or requirement engineering, where you collect the requirement from the use case, and then you develop the ontology, then you publish the ontology, and then you continue maintaining the ontology. So these are the 4 main phases of ontology engineering, not going into the details of that. So in the next slides, I will kind of follow these 4 primary phases and then show you how, what are the different methodology and tool recommendation from the OntoCommons ecosystem. So in the ontology requirement specification, as you have already saw it in the first presentation, that we have a detailed template called ontology requirement specification document, where you can mention the purpose and the scope and the intended users and some of the non-functional requirement. But the most important part is that you have to come up with some competency question from your use cases, or if from your data, and there is a specific template included in this form, which is where you can maintain these competency questions. And these are detailed in one of our deliverable D3.4, D3.4, which has the detailed workflow and the explanation of this template. Now, straight going into the ontology development, and then, as I say, that reusing existing ontology is extremely important. And we have this stack of ontologies from top level to the domain level. And this is done, they are mapped through an import structure. And this is an example of that. And also the bridge concept, which we explained, will comes into the picture to glue different ontological concept. I will show how this bridge concept actually map these ontologies in the next slide. But then to use the ontology for your application, you need to kind of use this import stack so that you have a link to the top level ontologies wherever you are. But for that, it is good that you use some tool, and because the import structure is a little bit complicated. So we are kind of, it is already hosted, called Industry Portal. And there are many ontologies. Right now we are at 100 ontologies there in the Industry Portal, where you can search and find your a suitable ontology, one ontology, more ontologies as you require. And there are recommended tool. I will show it a little bit also online. But then this tool will help you in finding your ontology and then using it to get the import structure make sure that you have all the required required components in your import stack, and so that you can start developing. And then it will look like something like that. It is not fully developed, but the concept is that once you find your ontology, you can download the ontology and specify which top level ontologies you want your concept to be aligned to, and it will automatically create those alignment and give you the complete import stack. Sorry. And then once you find your ontology, then you can use some of the ontology editing tool. It is good that, okay, people are, as Hedy presented, that Protege is still very popular, but then we wanted to link some of this editing tool along with the industry portal, so you can find the ontology, and then at the same time you can start editing that ontology, create new concept, and then enriching it for your application. So going back, I mean, I want to show some of these. Let me share my. Okay. Okay. So so as I said, this is the industry portal, and then you can log in, and then I mean, you do not need any account to search through the ontologies. But of course, it is open for submitting ontology, which I will come a little bit later. The main functionality is that you can search through different ontologies, but then you can find your ontology which you required by this search, and then it can be that you are trying to find some very upper level classes, for example, device, but then it can be something very much application level, say, for example, washing machine. And I mean, I even do not know that how many ontologies are there, because people are submitting ontology all the time in the industry portal. So, so for example, that I found that there is a class for even the toilet brush in there. So, so it is being, I mean, being enriched every time. So more and more ontologies we will get. This the number of classes will increase. Another facility is that, okay, you can actually use this something called recommender service, and there you can actually put a particular. I mean, it can be a list of keyword. It can be a unstructured data like a natural language text or something like that. And then it can, I mean, it can find what ontology you need for that. I mean, whatever it can get from there. For example, like for this particular text, which can be from an use case, you can see that it will tell you that these ontologies are more more suitable for your case. Now, of course, it is open for submission of the ontology, and that is also comes as a phase after the development of ontology. You need to publish your ontology, and then Maria can talk more about that. I mean, she already talked about it in the presentation. And so how much time do I have? Oh, okay, this is really short, but okay. Okay, I will try to take a little bit from there. Yeah. Okay. And this is open for your ontology submission. What is important is that we provide a detailed metadata for submitting your ontology, and then there are almost 200 fields you can populate your metadata with. if you want, I can see my, but then what it does is that it helps in making the ontologies more and more fair. And we already have a tool which kind of help you to find what is your fair score as you okay, everything is conspiring against me. Like, so you can find what is the fair score for your ontology. Okay, now going back very quickly as I'm running out of time, and then this also doesn't help to share screens. Go. Okay, so now very quickly, I will go to one case where I wanted to show that how this breach concept actually help in mapping the ontologies. Sorry for that. Sorry. Ah, okay. I'm missing one term from this. Okay. Is the slide still visible? No. Okay. So, for example, like, I'm not, I'm missing one slide which has the data, but then you can see it in the YouTube channel. We have already presented this demonstration in detail, but very quickly, that if you have some data, for example, like, and this is some sensor data modeled in an ontology called IOF core, and say this, you can see this is some this is some measurement data. For example, like it is measuring the temperature of some by using some temperature sensor, and then it is trying to measure some temperature of a water tank. And then you can model the same data also with Saref code, for example. And then they look a little bit different. The pattern will be different because they are modeled with different ontologies. The the idea is that this data, if someone is modeling with Saref or someone else is modeling with IOF code, they can talk to each other. So this bridge concept, what it does is that particular classes, then you can make some of this mapping with the bridge concept. For example, here the Saref device and the IOF piece of equipment has been mapped to the bridge concept of OntoCommons equipment. And by doing that, when you do when you run the reasoner, they kind of map this data from one class to another. One example is that you can see that there is a temperature sensor here, which is declared under IOF code, and there is a temperature sensor which is declared under Saref. But as you have the mapping between the IOF temperature sensor and the Saref temperature sensor, this mapping is helping this particular instance, the data point of temperature sensor at 30 centimeter depth, to be automatically classified under IOF code. However, originally it was only under Saref. And that happens because of the bridge concept. And also there is another benefit of that if you provide some wrong mapping, say for example, you say that temperature measurement, because it is a little bit problematic to understand what is the measurement class of Saref code is, maybe it is a process, you say. And then you say that, okay, temperature measurement is a measurement process, and you are trying to map it to the IOF code as a measurement process. This will give you an error because in SAREP code, this is not a measurement process. So I do not have time to actually show you this in reality in Protege and stuff, but it will probably go a little bit more technical. If you have any question, I'll be happy to answer. Thank you.
Thank you, Akko. Let's have a look into the chat. Is there anything new? It doesn't seem the case. Are there any questions from the audience? Otherwise, we can continue with the next demonstration. Okay, thank you, Akko. Really interesting. And now the next speaker here is María Poveda from the University of Madrid. She will demonstrate the demo for fairness score verification.
Okay, so I speak here, right, and present here. Sharing. Oh, we have the laptop in the middle.
Is it because we don't see it? I don't know.
Yeah, I'm not. I'm in the middle of the laptop. Yeah. No, okay. Oh, but yeah. So okay, so this is a continuation from yesterday's talk, so I will skip some slides. Just to mention that the FOOPS, that is the system I'm going to show, is based on the linked data principles and the 5 stars ranking, the 2 rankings. Okay, yeah, no, sorry. And here you have the links I mentioned yesterday, the 5 stars. And now is this me? Okay, thanks. So we have the design issues from that are the principle from linked data from the web consortium, actually from the Tim Berners-Lee, and then the link to the blog post that I mentioned yesterday about the 5 stars vocabularies, and also the paper from the Semantic Web Journal. We also considered the best practices publications that Daniel Garijo and me were compiling. As I said, nothing new. We are compiling in one document recommendations that are here and there. And then we developed some tests. We automated some tests that we implemented in FOOPS according to the FAIR principles applied to the semantic web ontologies. And then we have tests and some explanations about why we are checking this and how you can solve them. There are some guidelines, small guidelines. And yeah, it is practical because it is based on years of ontology engineering practices that we do at the ontology engineering group. And you can go to that permanent URI that redirect to our service and try it. That is what I'm going to do later. So what you will find is a very simple interface, because if I do something with software, it's just simple services that you can use very quickly. I don't like a complex software that serve for everything, but we really focus in specific functions. So you just include your URI. There are some tricks that I'm going to do in case you don't have a URI yet. And then you get a score of your fairness. And we like to say that this is not a stamp. It's just to show you how you can get higher score, and there is not a threshold. We don't say you are fair enough from now or not. So if you get 60 and you go to 80, we give you the recommendations. And then the tests are classified by categories, that is findable, accessible, interoperable, and reusable. And for each category, there are different tests. For example, the interoperable test 1 says, the principle says metadata use formal, accessible, and shared and broadly applicable languages for knowledge representation. This is the principle. And then our test is RDF1, that is, we get some RDF for your ontology. But for example, the second principle have several tests. Each test can have one or many checks, but that's implementation details. And well, we also give this radar to show you easily in which dimension is more likely that you can improve. Yeah. So this is a summary of the test that we have for each category. So the URI is resolvable, is persistent. There is a version IRI that also resolves. There are some minimum metadata that is our minimum metadata that is very minimum, is less than 10 fields, I think. Whether you register the prefix and the ontology in registries. You can register the prefix in registry, register the prefix in some service and ontology in other services. For accessible, whether we can retrieve RDF for machines and HTML for humans following the content negotiation. Whether the ontology is in a registry, which is repeated because that means that it is findable and accessible through the registry, and whether the URI has HTTP or HTTPS protocol, because it's what we use in the semantic web. Yeah, interoperable, whether at least it is RDF, and whether you are reusing well-known vocabularies for metadata, and also whether you are reusing other vocabularies within your ontology. And about reusable, whether you have the HTML representation, those points are also repeated with accessible. Whether you provide more metadata, that is the one that we don't consider minimal, we check it in reusable. Whether there are labels and description for all the terms, not only for the ontology, for all the terms. Whether you provide a license and whether you provide a provenance information. And if you have any comments, you can open issues in the GitHub repo, or you can download the code and implement that in your service. And let's try. I'm going to. Okay. So let me. I prepared some. Okay, here. I prepared some ontologies for doing this. So what I did was to publish some, to get some ontologies in a GitHub repo. And what I can do very easily is to get a W3ID identifier for my OWL file. So I did this morning. So here I have the example pre, because I was trying to do 2 evaluations. Let's see how it works. And then it redirects to the ontology. And here we can see that in the RDF of the ontology, there is only title metadata for this one. So I'm going to take, this is not the URI, okay? This is the URL. It's different, but I'm going to make it for avoiding the demo effect. So here, instead of having the link exactly to the file, I should have included the URI, that is my published ontologies. That is this one, that is the permanent URI. So, and it is good to have this permanent URI because now it redirects to this, but if tomorrow I want to change the location and put it in my server, it wouldn't be affected because people will still use this, because people doesn't need to know about the technical details where I'm storing that. But for the purpose of the demo, I'm going to use that. Then I run it, and we have a funny crescent while you wait. And then the system extracts some metadata, like the title, license, but as I didn't provide the metadata, the system cannot check it. And then this is the scores that we get. It's not really findable. It's not accessible. Well, a little bit accessible because we provide the RDF, the HTML. The RDF is also provided in Turtle, XML, JSON-LD. And we get less than 40%. I'm not checking the time, by the way. If you can give me a sign when there are 2 minutes left, but I think I will be on time. So here we have the results by category. So findable, okay, we have a persistent URL. I think it get it from the file, this pool, not from the, I included a GitHub link, but inside the file, it is a W3 ID. That's why it says there is a permanent URI, because it got it from the file, not from the input. The ontology is resolvable. We can check the HTML and the files, but we don't have a version IRI. Of course, if we don't have a version IRI, it doesn't resolve. We don't have consistent ontology IDs. The thing is that I'm copying and pasting files and then change the URI somewhere, but not in other places. So, and also I included in the system, I included the URL. So the URL doesn't match the code URI. So it says, this doesn't match. You are saying this is your ontology, but it's actually that one. We have some minimum metadata because I have the, I think I left only the title. So we have that, but yeah, exactly. The title does not appear here. The system tells you, I'm checking title, description, license, and these ones weren't found. So description, license, version, URI, author, that was removed. The only thing that was there was title. That's why I got 17%. There is no ontology prefix. I didn't register the prefix. There is no ontology metadata in any registry. And well, we could check others, but you can play with this. Further, I think maybe the ones that you might be more interested in is these ones, the minimum, the recommended, and the detailed metadata classifications that we have, just to define these minimum requirements. So imagine that we go, actually, I have here the examples, pre-example and box example, and from this GitHub repo, I also publish the ontologies with the W3C, and in this case, I gave another URI. So in real life, I will go to the first one, make changes, commit, and republish. But we are having many issues because we have to do some git clone that is not working. So I fake it. So I'm going to copy this link. Well, I'm going to show you first. If I go to this version and I go to the RDF XML, then I included here all the metadata that they asked for. And if you see, the metadata is together with ontology. So we don't have this way of checking whether they are linked because it is embedded. And then I'm going to copy this and go to FOOPS now and paste it. By the way, there is also a web service, so you can plug the service in any other system you are building. So in this case, the system will get the title, the URI, and the license, and we just display this information because I think it's the more important for us, whether there is a license and the title. And now, as we just including the metadata for the ontology, we didn't include it more for the content. We made it more reusable, I think more findable. It was before it was lower. Yeah, but it doesn't change the accessibility. Actually, I should go and check. And that's all I wanted to show. You can see that it is pretty simple, and if you have any comments or suggestions, we are working on it still. Thank you.
Thank you, Maria. Are there any questions from the audience in the room or remote? Here's a question from Sylvia.
That's very quick. Thanks, Maria. Are there restrictions on the format? Like, does it need to be RDF, XML, or can it be
Turtle or RDF XML? Probably N triples will also work. I think it is based on yeah. So it should be all API, probably, or I think it's all API, so it will work with Turtle, RDF, XML, N triples, but normally Turtle works better.
Okay, thanks again. And our next speaker is Pablo de Andres from the Fraunhofer Institute for Mechanics of Materials, and he will present the marketplace that was already introduced on the first date.
For time's sake, I will skip slides and try to keep it around 10 minutes because I think you will probably get a better impression of marketplace if you can go to the break earlier rather than get more information. I had the page here, but I think it's gone now. No, it's there. And I need a timer. Okay, so I will basically elaborate on what Dirk presented on the first day, try to show it live and then add some more extra information on this. This is the landing page. I'll use the staging version because it has the latest code, but basically production is very similar. Login via Keycloak. There is some other login options here. For the EOSC pillar project, for example, we added the login via the EOSC pillar Indigo EAM, but we need to solve some legal stuff before we can open this completely, so it will be activated then. This works. Yeah. You might also realize this is slightly similar to the DSMS presentation in terms of GUI because there's this knowledge app component that is used by both, but you would see it's actually quite different in terms of functionality. Have here the three main components to create an element, explore, and store. And the store. If I create here, I can create knowledge items. Have different types, so I can create an organization, register my organization here. I can define myself as an expert or a technology, and then we have apps. These right now are two items, but will be unified into one. And I will start by registering an application. The name is going to be database. Just for a bit of background, this is something that we did also in EOSC pillar with colleagues from INRAE. They have a data repository. I believe it's mostly for agriculture data. And we did an application for Marketplace where they can connect, where we can actually browse their information on Marketplace. Doesn't fit maybe completely with materials modeling, but it's more of a demonstrator to show how this can be connected and browsed. So I call this database. I confirm that I have the rights to create this app. I can create it. And then here I can add some metadata. I can add the picture, change the name, add some summaries. I could edit information regarding the materials as discovered and so on. Like I said, maybe it doesn't fit with database, but for materials modeling information, we would define this. These are all ontology classes. This is something similar to what you saw for datasets on DSMS. So this is the component that is shared. I can also connect this to different people. So I could say I'm an expert of database. In this case, I'm an expert of the app, not database itself, but I should be here. This also allows me to browse later this kind of knowledge graph to say, okay, it's Pablo, I'm here, I work for this organization, I'm an expert in this, or I know these apps, and you can browse it this way. And this would be the knowledge item side of of the Dataverse, then we can connect the app. To connect the app, we go to this dashboard, and in the admin console, we upload the app, so we register it here. I need to give a callback address just in case we want to support login in the app itself. Just for this, I will just say this is test.com. For demo purposes, I can also define some scopes. We also have the concept of host and resident apps. So if I register something like AIDA Lab, I will only have one login via AIDA Lab, but then all the different apps inside AIDA Lab will use this login. So these are different options supported here, different authentication flows. And then I need to update this Open API, this Open API. This is a document where I define for my application. Let me find it. Can't do both things at the same time. So for my application, how does this map to Marketplace? Marketplace defines a list of what we call capabilities, which says, if you want to check that your application is running, you need to have this thing we call heartbeat. If you want to start a new simulation, we call this new transformation. And then when you register your app, you basically have an Open API specification, and you say, if I want my application support these things, and the heartbeat is on this endpoint, and the new transformation is this endpoint in my application, you define the payloads. And this is how you register new software to the marketplace, by defining this compatibility. So once I register this, I will get some information. This is useful if I want to allow in my application for users to log in via our marketplace. So we use a unified login. And basically the next step is for an admin to accept this. Luckily, we have here in the front row an admin, so I'm pretty sure he's accepting this right now. Once this is done, what you need to remember here is, in case there are multiple applications, that the unique identifier is this client ID. So A5. This has magically been approved. And then I can search this. And depending on the amount of apps, it might take some more time. It was A5. This is just a backup I registered before in case everything broke. I can link it and then say, well, this knowledge item has this application. Then we would have the pricing section where I say, as a user, so this is what I do as an app developer. I register my application. This is now on Marketplace. Then I can change my role, and now I'm someone who wants to use this. You can find this actually by going to the different Explore place. I will show this in a second. You can also go to the store and then see, oh, okay, here we have Dataverse somewhere. This is not the most efficient way to find it, but just so you see here in Explore, you basically have all of the items. And then I find here the item, and I say, oh, okay, here I have all the metadata that I before, but someone else defined. And I can say, okay, now I want to buy this. You can go to the purchase, buy it, and this allows you to, for example, test it. So this is just a Swagger integrated into the platform, where it uses this Open API to render it here. You can test different things. That these capabilities that you said my application supports, you could test them here. This is, again, test purposes. This is not really how you would use the app in the long term, because it's not very efficient. But what we said that this Dataverse app supports is the heartbeat, to see if it's running, to get some collection. So to get all the collections, to get a specific data set, metadata for a data set, and then this global search, which is a bit specific, like different. And I will explain this in a second. But I could, for example, just try to get some data sets for data from the Dataverse, and this works. Won't go into detail because we're already on 8 minutes, but maybe focusing on the Explore page, which I think is something very interesting in terms of, I'm a user, I need to find stuff. How do I actually navigate this? We have different data sources. You can say, I look through all of that. I only want to find the knowledge item, which is what I just defined before, this Dataverse app. I only want to find applications. I can search in our forum. This is something we have here in the Learn and Discuss. It's a discourse deployment, different apps and workflows. I can also filter, similar to what Tobias showed for the DSMS. I can filter here based on the metadata, but not to repeat myself. We are interested in ontologies here. There is currently no knowledge item that has anything to do with ontologies, but here we can see that I search on the applications, and I can see that this comes from the Dataverse app, and basically this means this, because of this app and the connection that I did with this global search, it's going to Dataverse, it's querying things, it's using the search in the Dataverse for ontologies, and these are all the items in the Dataverse. I can click and open one that have to do with ontologies. So this is a quick way to kind of browse different repositories, and you get the information here. And you can actually see also here we have stuff in the forum. So someone created in our Discourse deployment some information about ontologies. Okay, 6 minutes to go. This is a very brief and quick way to describe everything. Then I want to also show what we did for this use case one. This is also something Dirk mentioned, where you have a laser going through a powder bed. This melts the powder. This is one app. This is sympathics. And you can also see this here. So we register sympathics. And then we use another app to check how this solidifies later. And this is the micros. And for this, I will use a video and just skip through parts so we make this a bit more efficient. But basically now we will show how you can actually make an app that uses multiple apps to show a workflow and maybe a bit more of a realistic calculation. But so you are also seeing here, or you have seen two kind of aspects. You can browse data, you can use this as a data source, but you can also use this for transformations and actually do some computations. Some context, we have this AIDA lab deployment for, I don't think you can read it, but it says there materials marketplace. So for the marketplace, we developed different apps. That's the sympathics, and then this micros app. And what this uses is, we don't want to go through the Swagger, and we want to make also users to be able to utilize this in a more efficient way. So we defined a Python SDK, so a small library, which is on GitHub available right now. And this allows people to control the apps, so call the endpoints through Python methods. So you don't need to do requests and handle that. Also for information, these capabilities, so these different endpoints that Marketplace supports is also a standard app API that we call, and it's also kind of like currently publicly available on GitHub. But basically we have here two apps. I start by opening the sympathics one, and this is using the IPy widgets and the Voila plugin, a simple notebook. You define a GUI, and then this GUI directly calls via this Python library that we defined the platform. I define some inputs for the use case. So this is again the first use case of Marketplace, the strength of the laser, how fast it moves, and some information about the powder bed. And you can start the simulation, and then you can already run. It's a very simple example just for demoing. And then you can, export the results. So you can go through them and see them. And this would be just one app, but the use case exports this and connects it to micros. Don't want to go into the details of the output format and so on, but basically I can then open the micros app, and this is the micros app, and then I can choose what's the data source and the application, the transformation, the unique ID of the transformation. I can load the data and then choose some other input if it's needed by micros, and directly run the second step. And this right now is two different notebooks. This could also be integrated in one notebook, because you have Python notebooks. You give it a token of your user, and then you can run everything. And I think I will cut it here because it's 2.5 minutes in case someone has a specific question rather than trying to finish this. But basically, two different apps connected via the marketplace and then the user. And this is a really nice way of demoing this, because you don't need to know how requests work. Even if I made this notebook for you, you don't even need to know how to program anything. You have the sliders, you click, and you get a quick, or well, slow depending on the simulation time, but result. Yes. Any questions? I don't think I can see the chat. Can I see the chat? I can see the chat. No questions. That's great. Okay.
Okay, thank you, Pablo. Also from the audience here, no questions. So thank you for this demonstrator. For our next session, initially we planned a 10-minute break. If it is okay for you, we would directly start with the next session because we already are slightly delayed. So if someone needs a short break, please take it. Otherwise, we could start with the next session.
It's me again. So for this session, we actually had 3 Q&As. I'm moderating this. I'm not going to talk about Marketplace anymore. We had 3 different Q&As about the 3 different topics. I think it might make more sense to actually just open the floor for questions in general, rather than trying to give 15 minutes to each. So we have a panel of experts, which I need to find the list. I think we can just stay like this and maybe ask questions directly. So for the OCES, there is Arko. Then for FAIRification, it would be María and Yann. And then marketplaces, it would be Yoav, Dirk, and Amit. I think we know all the speakers. They've given us already some information these 3 days. Maybe also a chance to ask questions if today you didn't have time during the other demos and talks. Is there anyone already with something burning to ask, or should I ask something? I think maybe then, okay. First question is something that we have, I mean, some people already mentioned, and there is now, this fever of ChatGPT, artificial intelligence, how it can do everything for us, but then maybe not really everything. We have here, I mean, 3 different aspects, right? We have the OCE, the FAIRification, and the marketplaces. But what do you think these technologies can bring to your marketplace FAIRification process? What is something that can be used? What is something that maybe is not there yet, but you would like to see? Is there a risk to us? Well, maybe we don't want to go into that side of the AI, but please.
Yeah, I was going to comment in this line. I mean,
maybe say for the audience your name.
Yeah, sorry,
Okay.
Silvia Chiacchiera here. I was going to say, can we think like, I mean, we mostly develop ontologies by hand, right? And is there how do you see this combining with automatic extraction? Because I've seen certain ontologies or taxonomies created automatically, and then as a human, you look at them, some things are a bit. Do you see this combination as a possibility to lessen the burden on humans, and or what do you think? I mean,
Are you asking anyone specific, or?
Oh, I'm looking at Maria, but I mean, it could be Maria, Arko, Eddie. I mean, all of us. I think it's in line with what you just said.
Yeah,
I mean, how does this connect? Do you see it?
I mean, I'm pretty sure if you give some text right now to ChatGPT and ask it to identify items, and maybe you can give it some RDF, it could probably identify which ones are in the text. So something like this, along these lines.
Do we see this collaboration, or it's?
Yeah, well, actually, I think, well, many people has done like, please make an ontology about sensors for me, and ChatGPT write perfect RDF taking SOSA and SSN ontologies and so on. So he reuses ontologies, or she reuses ontologies, or it reuses ontologies out there, and provide a model with concept and classes, but and there were a lot of work in, it was called ontology learning in the past decade that didn't really took off at the end, because the machine learning algorithm wasn't that great there, or the natural language process was not great. So I think that it could be a nice combination, but we really need the human in the loop, because at the end, creating the ontologies requires a lot of background knowledge, both in the domain and in the ontology language paradigm or rules, because not all the ontology languages have the same semantics and the same way of modeling. It's very different if you are in the description logics or in frames. So, and I doubt that the machine right now can make the decision that we do as humans. So you always need the human in the loop. And I think the distinction with ChatGPT is that it works with unstructured data. But if we had structured data, terminologies, and resources, there were already many initiatives to generate the ontologies automatically, because as in the same way that we use mappings to map data to the ontologies, and then we get the RDF data, we were also using mappings to map data and structured resources to OWL, which is the meta-level ontology. So the data from OWL is my ontology. It's just the same process into different levels. So we were already automating that. So the difference is about the unstructured data that is test mostly. And it will be great to have that supporting us, always us reviewing that. Because, for example, in the SAREF ontologies that we develop for many extensions, we always try to base our ontology in standards. And it's so difficult for us as ontology developers to understand, I don't know, industry standards, then building standards with IFC and so on. Then we develop for agriculture, then go and look at those standards. So if you can have something in the middle and overall providing provenance links, like, okay, I create this part of the model because I read this paragraph there, that would be great.
Thank you, María. Yes, I mean, I wouldn't say that the tools can replace a human, but I guess if we think of ways where we can combine them smartly, why not? For certain, as you said, now for certain tasks, very specific tasks. And
actually, this reminds me of the question I wanted to make to Hedy, but we didn't have time. So yeah, it's clear that we have a bottleneck when building ontologies, because we need domain experts to understand more or less OWL or the ontology language so that we can have the conversation. And also it's mostly a manual process. And we have another bottleneck when people need to understand ontology to make use of that. So my question was, which is the balance or the percentage that we need in terms of training or technology? Because I think we are not going to solve that with technology only. We also need training. So how do you see it?
Yeah, thank you for this question. And also, I think there is a link with what Sylvia also asked about. Let's start by I had a meeting last week with my PhD.
Can we have another?
So he asked for an urgent meeting because he's scared and he's not sleeping since a few days because he's scared that ChatGPT replace him. So, and one of the say, yeah, what if ChatGPT replace me and can develop ontologies and so on? So what should I do? So we say, if it will generate ontologies in place of humans, so you do nothing, just be human. Regarding the cooperation between the machine and the human in the ontology engineering process, so in lot methodology there is this phases, and I think there is in let's say in the in the first stage, for example, when we acquire knowledge from the domain. So it can help. It can help by providing, for example, a first set of terms, for example, to analyze the competency questions and give some terms. But ontology is not only terms. Ontology should present semantics. Semantics should be well expressed with axioms and well defined. Because the question is, and I usually make relation between the human intelligence, how we build the human intelligence and the machine intelligence. And usually I give the case of my daughter. So kids ask questions. What is? Daddy, what is this? I can answer, but the human intelligence say, yeah, but regarding your answer, they ask another question. So if you say, what is this? Say, this is a computer. The answer of my daughter will be, what is a computer? I would say, yeah, what a computer is a machine that allow you to process data, do some operations. I say, what is data? What is operation? What is inside the computer? So are we able to express that kind of intelligence to well define what is behind the term? It's that there is terms, but there is concepts in our mind and there is symbols. So how to make this link, this triangle of meaning? So I don't believe at this level that machines can do it. But also there is this gap between who can well define this and write this to get value. And as you said, I mean, it's not a matter of just languages for coding, or it's not just matter of people doing philosophy or people doing IT. So I do agree with Maria that it's a matter of training and putting people around the table and doing this, bridging the gap by putting people together, discussing and explain, make people interoperable. That's amazing. It's scam again and again and again. Ontologies for interoperability, but to reach that, let's make people interoperable. Ontology can help to do that, but before ontology help to do interoperability, we need to make people interoperable. We are interoperable in terms of language. We can understand English, but do we understand in the same manner? Do we interpret in the same manner? So we can be interoperable in terms of the format of the language, on the terminology. If I say model, are we interoperable in interpretation of what is a model? If we ask all the audience what is a model, we'll have hundreds of different definitions and understanding and interpretation, because perspectives are different, domains are different, all of these aspects related to the understanding what is the semantic behind the terms that we are using. It's a mental process. And how to align this, I think it's by discussion, by talking to each other. I know that it's strange because we are in IT domain, but human in the loop. We can't do it automatically. We will not resolve it from IT perspective only, but human with our intelligence, we can create the artificial intelligence that can help us and we work together. Thank you.
So what did you answer to your student?
We said be a human.
Be a human.
Yeah.
Yeah, maybe the answer could be also, yeah, you can answer why you modeled ontology, but ChatGPT is not going to answer why. And it's one of the issues with the machine learning.
There is this, we tested, we say, okay, give us an ontology of manufacturing. Okay, that's came back with some terms. We say, okay, what is this? It's go to check any definition, give you a definition. Okay, but it's logically suitable or not? No. We ask it, okay, could you align what you provided to Bhave, for example? Not able. Could you give the difference between quality in Bhave and Dolce? I mean, which is also amazing. It comes usually with an answer. I mean, this is also a matter of trust. And the definition, I mean, it was totally the opposite. Yeah, and then we say, yeah, but it's not right what you say. Say, yeah, it's not right. I'm sorry. I'm just a machine, and and rectified, and usually not the right. Say, yeah, it's not right what you are saying. I mean, the worries is that the manner of how the answer is presented in nice manner to represent the sentences and so on. If people are not expert on this domain, doesn't know very well, it's a problem because it will become a truth. Because people will be convinced, I mean, will accept this answer and can be, I mean, then this person will meet Rita, for example, will explain to Rita what he learned from ChatGPT, which was wrong. And it will be disseminated. And so this is the question of how we can trust that and how we can, let's say, block this kind of misunderstanding and giving a wrong answer that can be disseminated everywhere. So this is also a big ethical aspect that we need to take into account.
There's a question by Yann. I think, is that Yann? No, sorry. Function. About whether there is, if anyone knows if there is any work being done on automatically extracting data from patents or papers and automatically mapping them to ontologies. And there's even a suggestion of a workflow to extract the data, to do or define a vocabulary, mapping and convert, and then manually add if this vocabulary is not included in an ontology, and then upload this. Is anyone aware of any work on this?
There is a tool very recently published. It's called Frodo, and it's like based on an earlier work on NLP, which can process a natural language sentence or a paragraph.
Can you, yeah, maybe just
okay,
yeah. Closer.
So, and then ontologize the entire natural language text. However, I mean, of course, if it is like whether it can do it correctly, and then with a particular model, ontology model, the user wants to know. It cannot. It has a predefined model which it will always follow.
Also, another aspect I think related to the make the difference between terminology, terms, and concept and reality. So this, I mean, this is important. Ontology, not terms. So an ontology is, I mean, a terminology, no, it's not an ontology. Let's say that. Vocabularies are not enough to do ontology.
When you were talking before, Hedy, about whether we trust the output from an AI, you know, whether this is actually, this brought me back to the point that has come in different sections or in different aspects, I think, on this talk about, on this workshop about standards and bodies that standardize, you know, ontologies, but also we talked about standardizing FAIR. That is not something you can just define one standard on FAIR, but maybe you can define different aspects and different things that help you achieve this FAIRification. Is there any thoughts from anyone on next steps on how to define these bodies or how these standards should be defined? What work needs to be done there? I don't know, it's kind of a big question, but.
I want to comment that the last statement in Maria's presentation that that she said that the FAIR does not evaluate the content of the ontology. And this is probably, and of course, this is also controversial. And I have heard, I mean, many people clearly saying this is not the job of FAIR. So it can be, it is not in the purview of the fairness. But then whether it is under FAIR or not, it really does not matter. But then it is not enough to just find an access and ontology and then say some interoperability and reuse. The interoperability and reuse needs to go to the content of the ontology. It cannot be like I have some header information of the ontology and I can start reusing or like start making it interoperable. It needs to go to the content.
But,
Maybe it is under FAIR or not, that is up to the discussion for sure.
Kind of two aspects, right? Whether you standardize ontologies and whether the contents are correct, and you have someone that checks that this is correct, and whether you verification of data in general. And as a byproduct of this, we say we need to also verify the ontologies that control this data, right? So I see this as two different aspects. One's where you make sure that the data and byproducts of this, if we can call this ontology byproduct, so how we verify this, if this is correct, and then if an ontology is correct. Could be two different sides, right? Two different things that needs to be standardized.
Yeah, I mean, let's say when we talk about the fairness of data, if you take ontology as a data, I mean, the file, this to make it fair, that's, yeah, this is standardization in terms of fairness as it's defined. But also what I think Arko is talking about, which is very important, is the standardization of the content as ontology. As I mean, there is the file that should be standardized to be accessible, to be. I mean, we can process it. This is the let's say the computer science vision of things. Focus is there, but there is a domain perspective inside that should be fair, and there is standardization work to do in order to make fair the semantic content of the ontology itself. So yeah, I mean, standardization effort should be, and fairness, in my perspective, should be inclusive in terms of the content, or maybe, I mean, use another term, but fair of the content, I think is important also.
So yes, if I may. So I agree with you. I mean, the fairness of the content is important. Now, we need not to be mistaken. Fair does not relate to quality. It can contribute to quality, right? If your data is fair, I mean, it's documented and you can reuse it, it's interoperable. It doesn't mean that it's good, right?
Yeah.
We need a microphone.
Sorry. So it doesn't mean that it's good. And that's why you have this EOSC association task force that looks at two things, fair metrics and quality, and how they interact with each other. And quality of data or even ontology is a complete other realm. That's extremely complex. I mean, what would be the quality criteria on which you would evaluate an ontology, right?
Yeah.
Certainly logical foundations, the hypothesis, and so on. So it needs to go deeper on what an ontology is and how it works. So, but I would not conflate both, right? Just that it contributes one to another.
Yes.
But yeah, it's important to consider the ontology as part of data because, well, you use them to annotate your own data. So in a sense, it's part of the whole thing.
Yeah, if you allow me just one comment. So I followed what Hedy said. So the FAIR and all that stuff, they have to do with the data themselves as data and their quality as data and data management, which is very important, from the computational or the IT aspect of it. So I'm an engineer and I'm interested on the real use of ontologies, which is to build solutions in knowledge graphs or digital twins. And there we are taking care, or where we need the meaning of the data to interpret the data and take good decisions and support for the applications. So there are the other aspects that are discussed also in OntoCommons and in IOF, etc. So how to define the ontologies, how to select the terms and use the terms and the relations between the terms, how to define the terms, provide good definitions in natural language, and also go further with the mathematics with formal logics that guarantee the logics, so the quality of the logics and the ontology from this point of view. And then the final quality will be judged by the applications, by humans, when we need computer scientists, ontologists, and subject matter experts to judge the quality, and the quality will be the use of the ontology. If an ontology is used by practitioners, by market, by business, then this will be the proof of its quality as a product, as a logic, as whatever we want to do with the ontology. So the rest, fair, etc., is the quality of the data, the practicalities, which is very good. We need to have it for the maintenance of the thing and all that stuff. So the quality of the ontology itself as a product to be used by practitioners has other implications. Thank you.
Well, the ontology quality is like my topic, so I cannot leave it without the comment. So, well, there are in the NEON methodology and in the past, there are many ways to evaluate ontologies. And of course, when we say these days, oh, we don't have tools and we don't have means and we don't have methods to evaluate ontologies, what I think what people really means is that I can't do it with a click or easily, because there are methods, but that takes time, which means money. And there are tools that give you some insight about, okay, the ontology is run in this way or this other way, but to really check the content has to be done by experts, and that is the bottleneck. And everything, when something comes to domain experts or experts, that's the bottleneck and the expensive process, and when we complain. And then one of these, so we can check the syntax that was okay in the 90s, but since we have the many APIs for building ontologies, we don't need to check the syntax anymore because we don't write them in a text editor, as we do with the code, of course. But that was an aspect. Then we can check the logical consistency, and then we have many reasoners, even though we use that more or less wrong. And we also have systems that develop, that detects like common errors, but will not necessarily lead to logical inconsistencies, but something that you should check again because these are like anti-patterns. And then you can also use whether your ontology covers your data, that is the application. And the final aspect is the whether others are using your data, but I wouldn't measure that really as quality, but as I will measure that as a KPI for success or for impact. Because you can also have not so good ontologies, but being highly reused just because they were the first ones, or they were like, okay, it's not perfect, but solves my problem. So being used for me is not directly implies that it was with quality. And just that is back again to the, okay, how we are going to solve this, training or technologically. And every time we need background knowledge and experts, we will have a bottleneck for sure.
Maybe that's something that we need to focus on, to either make domain experts more aware of ontology, or making this communication between the experts in ontology and the experts in a domain more.
Or how to,
smooth.
I don't know, how to have intermediate representations of something from that we can feed from their conversation, or maybe how can we generate perfect circles, shapes as we talk to the domain experts so that we can check that later, maybe. But at some point they need to check the structure of the ontology, and you have to make them to understand what you mean by this owl axiom. That will be also important. And well, I'm saying because if you realize the system I presented is FOOPs that just add an F to the system I developed many years ago that was called OOPS, that looks for these anti-patterns. And then I had a long list of anti-patterns that I was checking manually, ontologies built by people. And then I said, okay, I need to automate the detection of this. So there is a subset of pitfalls that I wasn't able to automate because they required background knowledge, and that depends on the domain. So I cannot have a general check for the ontologies in industry, materials, biology, and so on, because that depends on the domain. So when it gets to real knowledge, it's very difficult to automate that. So we will complain, there are no tools.
Maybe this is not needed to automate it. So
Sorry?
maybe there is no need to automate this process because it's a human process, and
because we need your student.
The thing is to organize it properly so that it is cost effective, but it has to happen. And then there are communities, there will be communities that they will do this job. So.
Yeah, exactly.
I want to just add one more point. I agree to everything what Maria said. Just want to add one more point and then of course this may ensue some more discussion and maybe it is my belief, and then I think that as Eddie was mentioning, that there is this retrogression of the question, like what it is, and then you go granular. I think a good ontology needs to somehow link or go up to those domain neutral and generic concept to explain all its predicate, whether it is a relationship or a class or a concept. I mean, the explanation needs to somehow reach to a point that you can have the definition reduced to some of those completely general and then domain neutral terms. And now what is domain neutral term? And there is a consensus for sure, like say even process, but recently ISO 21838 actually have a list of this concept, which can be considered as a top level concept. Now, I'm not advertising for any particular top level ontology, but I'm saying that if we use this one of the top level ontology, maybe which kind of like addressing those list of general concept, I mean top level concept, then we are good in shape. Like, so this should be a practice that all the predicates are somehow reduced, can be reduced to those general domain neutral terms.
I'm afraid I think it's a good discussion, but it might speed off